Alright guys, here we go, moving on to three variable systems. Now, I didn't reprint my copy of the guided notes, but you'll notice that I have split section 6.2 into two pieces. We're going to cover the first part today, where we're still focusing on linear equations, but this time we're going to be solving systems with three variables, x, y, z. Section 6.2 in this book is really big, so we will switch gears and look at matrices when we get to the second part of chapter 6, section 2. Okay, just like with our two variable systems, a solution to a system has to satisfy every equation in the system. It's just that when I have three variables, I have an ordered triple instead of an ordered pair. Now, in other books I teach from, it's always alphabetical order, X, Y, Z. I have noted that in this book that is not always the case, so just pay attention as you work through the problems. Make sure that you read things carefully. If you have three variables, you need a 3D coordinate system. We talked about this in section 6.1. The z-axis is going to go through the origin, and it's going to be perpendicular to the xy coordinate plane. I can't draw that, but think of, you've got your xy coordinate plane, 2 dimensions, length and width, and you've got your z-axis perpendicular to that heading through the origin. The graph of each equation is going to be a plane, like a sheet of paper, not a line. Now, just like with our two-dimensional system of two variables, you have three possible ways things can go when you have your solution sets. The first one is that you have one solution. And I don't know why that doesn't say that over here. So number one, you have one solution. And this is an example of one solution. You have your three planes that are on the three-dimensional graph. They intersect at one single location. So if you have one solution, you have an independent system that is consistent because there's a solution, and your solution would be that ordered triple, that location x, y, z. Your other opportunity, your other possibility is that there would be no solution. So I have three different ways that could look. It could look like parallel planes, or it could look like planes, three different planes that intersect, where two intersect with another, one intersects with another one, but they don't all three intersect at the same place. Because this has no solution, it's an inconsistent system. They are independent of each other. All right? And then our third possibility is that we have an infinite number of solutions. This time our solution set is a line that all three planes pass through. This is a dependent system because it's an infinite number of ordered triple solutions, consistent because it does have solutions. Okay, when we are checking to see if our ordered triple is a solution or not, remember your answer is going to be yes or no. Unless you're shown differently, we've got this ordered triple XYZ. In order to see whether or not it's a solution, you have to check to see if it's a solution to every equation. Let's just go in order. X plus y plus z equals 4. I plug in my given ordered triple. 2 minus 1 plus 3 equals 4. Well, 2 and 3 is 5, minus 1 is 4. So it works for that first equation. What about the second equation? I've got x minus 2y minus z equal to 1. Well, x minus 2 times y minus z, let's see if that's equal to 1. So that would be 2 plus 2 minus 3 equals 1. Sorry, I'm doing math in my head, jumping ahead. Sometimes I can't do all the things at one time. 2 plus 2 is 4, minus 3 is 1, 1 equals 1, that's true. Can we stop now and say yes, it's a solution? Well, no, because for it to be a solution, it has to work in all three equations in this three-equation system. So our next equation, 2x minus y minus z equals -1. 2 times 2 minus a negative 1 minus 3 equals negative 1. Let's see what we get. 2 times 2 is 4, minus the negative is plus 1, minus 3 equals negative 1. This gives us 5 minus 3 equal to negative 1. That is not true. 5 minus 3 is 2. So my ordered triple does not work in this third equation. The answer to the question is no. This shows my work. This gives me the answer to the question. Now, you have to check every equation unless you come, if I tried it in the first equation and it didn't work, then it doesn't work for the system. I can stop there. But if it's working as I work through the equations in the system, I have to still keep checking things to make sure that it works in all of the equations. All right, solving systems of equations in 3 variables. We are going to reduce down to what we know. When we were solving 2 variable systems, we reduced it to a single variable, solved for that variable, and then plugged in. We're going to do the same thing. We're going to reduce, so we eliminate one variable, we reduce it to 2 equations and 2 variables, and then we do what we did when we started here. We look for the easiest variable to eliminate. We're going to solve that. This is to get down to two variables. We find the easiest variable to eliminate. We use either addition or substitution to eliminate it from 2 pairs of equations, because we've got to create a reduced system of 2 equations in 2 variables. So you have to kick out the same variable out of 2 different pairs of equations. Then you solve that reduced system of 2 equations, just like we did in the last section, section 6.1. Okay. So let's go through. We're going to start. We've got equations 1, 2, and 3. We need to make either x, y, or z add to 0. I could do any of those 3 variables. It's not going to matter. But I see that if I went with y, equations 1 and 2 are already set up for my y's to add to 0. So let's just start there. I'm going to add equations 1 and 2 together, and I don't need to make any changes in order to have y add to 0. So I'm going to copy the equations down just like they are. Now I do not have a key that shows me step by step for this one, so I hope I don't make any mistakes. I'll try to catch them as we go. X and 3x is 4x. My y's add to 0, that was my goal, plus 2z equals negative 2. This is going to be my 4th equation, and it's in terms of just x and z. I eliminated the y. I need to do another equation that eliminates the y. I paired 1 and 2. Let's pair 2 and 3 next. So if I'm going to add 2 and 3, and I want my y's to add to 0, this needs to be a negative 2y. So I'm going to multiply equation 2 times 2. So that's going to become 6x minus 2y plus 6z, and don't forget to multiply whatever that coefficient is to the constant as well. So it's equal to negative 4. I don't need to change equation 3. I can just copy it down, and it's going to have my y's add to 0. That was my goal. So I paired equations 1 and 2, had y add to 0. Now I'm pairing equation 2 and 3, having y add to 0. That gives me 7x, my y's add to 0, plus 3z equals negative 5. This is my 5th equation. Now, I focus right here. I've got a 2-variable system. I need to solve this 2-variable system for x and z. We know how to solve a 2-variable system. We did it in the last section. I need one of these variables to add to 0. I'm going to pick the z's because I can stay with smaller values. If I choose to make my x's add to 0, I'm going to have to do 4 times 7 is 28. Things get bigger. If I do z, I can use 6. 2 times 3 is 6. So I can keep my numbers smaller. And usually when I keep my numbers smaller, I'm less likely to make mistakes. So I'm going to add equation 4 to equation 5. I'm going to multiply equation 4 times 3. So that's going to give me 12x plus 6z equals negative 6. And then to make my z's add to 0, I need to multiply this by a negative 2 times a negative 2. So that will give me a negative 14x minus 6z, and that's a positive 10. When I add these two together, 12 minus 14 is a negative 2x. My z's add to 0, and that's going to be equal to 4. So when I divide by that coefficient, I get a value for x of negative 2. Okay, now I've got to work my way back up. I'm going to take this negative 2, I'm going to plug it in to either equation 4 or equation 5. I can't go all the way back to the beginning yet because I have 3 variables here. But 4 and 5 only have 2 variables. And it doesn't matter which one I plug it into. Let's just, these numbers are a little smaller, so we'll plug it into equation 4. 4 times negative 2, because that's the value I found for x, plus 2z equals negative 2. So that gives me negative 8 plus 2z equals negative 2. If I move that 8 over, just be careful with your signs, your pluses and minuses as you work your way through to make sure that you keep things on track. So I've got a value for x. I've got a value for, oh, I just made a mistake. I'm so glad I caught that. I need to divide by 2, which gives me 3. There we go. I've got a value for x, I've got a value for z. Now I can take these 2 variables, go all the way back to one of my first 3 original equations. Does not matter which one I pick, I'm going to choose number 1 because the numbers are smaller. And I'm going to plug those in and solve for my missing variable. So my first equation is x plus y minus z equals 0. We found x to be negative 2. We don't know why. Minus 3 for minus z gives me 0. So that's y minus 5 equals 0. When I add that 5 to both sides to move it over, I get y equals 5. Sorry guys, I'm bouncing things. So we found our variables, x, y, z. X, y, z. Don't leave it like this. Make sure that you write your solution as an ordered triple. And put it in the order the problem was presented. Like I said, I'm used to it being always x, y, z. I've noticed for this book it is not always x, y, z. So just pay attention when you're doing problems in my math lab. Okay, let's do another couple of examples together to see what we get. Here we have x, y, z again, so we're going to present our solutions in order triple. I can solve by starting out by eliminating any of these 3 variables, x, y, or z. Does not make any difference. I want to pick what's easy, and once again, I think it's going to be easiest for me to start by eliminating z, because I've got a negative z, positive z right off the bat. That adds to 0. So I've got 3 equations, 1, 2, 3. If I pair up equations 1 and 2 just like they are, and add them together, I create a 4th equation, 1, 2, 3, this is my 4th equation, 4x plus 6y, my z's add to 0, equals 28. Okay, so I eliminated z one time. I need to do it again. I paired up equations 1 and 2. I can either pair 2 and 3 or 1 and 3. I'm going to choose to pair 1 and 3 because I have a negative z here and a positive 2z there. So if I pair 1 and 3, I will need to multiply my first equation times 2 to get those additive opposites. So if I multiply my first equation times 2, it yields 2x plus 8y minus 2z equals 40. Don't forget to multiply all the way through to the constant. I'm not changing the 3rd equation, I'm just copying it down. When I add those 2 together, it creates my 5th equation so that I've got my reduced system. 2 and 2 is 4x plus 5y, my z's add to 0, that was my goal, equals 24? Yeah, 24. There's my 5th equation. So this is my reduced system. It's got the same 2 variables for both equations, x and y. Now I'm going to treat this just as a 2 variable system. I'm going to solve for one of these 2 variables. oh yay, my x's have the same coefficient. I can just make one of them negative. So let's do 4 and 5 and multiply, it doesn't matter which one, I'm going to multiply 5 by negative 1. So 4 I will copy down just as it is. 5 I'm going to multiply by negative. Negative 4x, negative 5y equals negative 24. Now if you did this on your own, you might do different steps. For example, you might have eliminated x, and then all of this will look different, your work, but your answer, your result, your ordered triple should be the exact same as mine. So my goal here, my x's add to 0. 6 minus 5 is 1y, and that's going to be equal to 4. That's my first value that I've solved for. Now I start working my way back up. I've got to go to either equation 4 or 5 to plug this in and solve for my second variable. Makes absolutely no difference here. Let's do equation 5. That would be 4x plus 5 times y, and I have a value to plug in for y equals 24. So 4x plus 20 equals 24. I move that 20 over, and then I divide by my coefficient, and I get that x is 1. Sorry, there you go. Alright, I have x, I have y, I still need z. So I'm going to take these two values, plug it into one of the 3 original equations. Does not matter which one. I'm going to choose to plug it into the second original equation. 3x plus 2y plus z equals 8. 3 times, well, x is 1, plus 2 times y is 4, plus z, that's what I'm solving for, is 8. So 3 plus 8 plus z equals 8. This is 11. 11 plus z is equal to 8. So when I subtract that 11 from both sides, I get that z would be negative 3. We are almost not quite done because we have to write our solution set as an ordered triple. X, y, z. Perfect. Alright, excellent. Let's look at our last 2 examples. We've eliminated x, we've eliminated z. I think we eliminated x first, and then we eliminated z. No, we eliminated y on the first one. You know what? We're still going to eliminate y again here because I think that it's easiest. It's not really. I could eliminate x really easy. Multiply it by negative 4, compare there. Multiply it by negative 2. You don't do x? We haven't done x. Let's just do x. Okay. Equations 1, 2, 3. We're going to start by adding equations. We're going to eliminate x just because we haven't done it yet. We're going to do equations 1 and 2, and we're going to multiply equation 2 by a negative 4. So let me copy down my first equation as it is. Multiply the second by a negative 4. Okay. That gives me my x's add to 0. That was the purpose there. My fourth equation is going to be negative 9y plus 6z equals 15. And then if I add equations 2 and 3 and multiply equation 2 by negative 2, and that needs to be minus 2 minus 4y. I get in a hurry and I start missing signs. Negative 2 times negative 1 is positive 2. The 3 I'm just going to copy down as is, as it was given to me. And that allows me to create my fifth equation. X's add to 0, negative 2y minus z equals 1. And let's hope I haven't made a mistake that I did not catch. Okay, we've got a reduced system with 2 variables, y and z. We want one of those 2 to add to 0. Let's do the z's to add to 0. We've got a positive 6 and a negative 1. So I'm going to just add equation 5 over here, I'm going to multiply it times 6. So right here, that gives me negative 12y minus 6z equals 6. And let's see what we get from that. This is a negative 21y. My z's add to 0 equals 21. If I divide by a negative 21 on both sides, y is equal to a negative 1. I'm going to plug that into one of these two. This one has smaller numbers, so let's plug it into equation 5. Negative 2 times negative 1 minus z equals 1. So that's 2 minus z equals 1. Negative z equals negative 1, which means if I divide both sides by a negative, z equals 1. And then finally, my last step, I need to plug in what I know for z and y into one of my original equations to solve for x. That's my missing variable. I'm going to use the second equation, just as it was given to us. We don't know x. 2 times y minus z equals negative 1. So x minus 2 minus 1 equals negative 1. X minus 3 equals negative 1. If I add 3 to both sides, I get that x is 2. There we go. Alright, x, y, z as an ordered triple. And that's my solution. Consistent system. One solution, so it's independent. Alright, last example for this section. Again, does not matter. I can choose to eliminate any of those three variables. I'm going to pick, because there's no one here to ask, I'm going to pick y. Let's do y again. So if I add 1 and 3 like they are, 1 and 3, x plus y minus z equals 5. X minus y plus 3z equals 3. Let's see what happens. That's 2x. Oh, you know what? Well, that's fine. I didn't color code, but we're good. Y is add to 0. That gives me 2z equals 8. That's my fourth equation. Now, eliminating y again, let's do equations 2 and 3. And we're going to multiply equation 3 times 2 so that our y's add to 0. Equation 2, x plus 2y minus 3z equals 9. And then 2 times the third equation, 2x minus 2y plus 6z equals 6. So our fifth equation, our reduced system, 3x, y is add to 0, plus 3z equals 15. Okay. So we've got equation 4 and equation 5. We need to solve for x or z, and I'm seeing something going on with coefficients here that makes me a little concerned. We are going to focus on adding my x's to 0. So let's make this a positive 6 by multiplying by a positive 3, and let's make this a negative 6 by multiplying by a negative 2. So if I multiply this fourth equation by a positive 3, I've got 6x plus 6z equals 24. And if I multiply my fifth equation times a negative 2, I have negative 6x minus 6z equals a negative 30. Now, when I add these together, my x's add to 0, my z's add to 0, so the left side of my equation is 0, and the right side of my equation is not 0. It's a negative 6. Well, does 0 equal a negative 6? It does not. Now, if I'm working this out on my own, if it's for my math lab, I can plug it in and check and see if, oh, is this no solution? If it's written, I'm going to probably go back and double check my work to make sure I haven't missed anything. But anytime you get this statement that's just not a true statement, that means that you have no solution. It can be presented as the empty set.